Hi, this is Mr. Anderson, and today I'm going to give you a podcast on significant digits, also known as significant figures, or sometimes we call them just sig figs. And so if I do my job right, you should be able to take a problem like this, 10.6 meters divided by 13.960 seconds, and come up with an answer that not only has the right number of units, or the right units, but also has the correct number of significant digits. So let's get started. We've got some snipers here, and what snipers try to be is they try to be both accurate and precise. What does that mean? Well, accuracy refers to truth. In other words, how close you are to the right accepted answer. Precision, however, reports to the repeatability. And so let's look at these bullseyes down here. This bullseye right here, the sniper has been fairly accurate. In other words, all the shots are pretty close to the bullseye, which is going to be right in the middle. So we would call this accurate shooting, but not precise. If we look over to here, this time all the shots are way off to the side, and so it's not true anymore. In other words, it's not accurate, but it's really precise. In other words, they have a really tight grouping right here. And so what do we hope to be as a sniper? We hope to be both accurate and precise. And what do we hope to be as a scientist? We hope to be accurate and precise as well. So let's say you have a wasp that you want to measure. And so if we measure this wasp from its head down to the end of its body, we find that it is 1, 2, and somewhere between 2 and 3. And so I might say that the wasp has a length of let me approximate, 5 centimeters in length. Why can't I get more precise than that? Well, my ruler is no better than that. And so if I get a better ruler, now I see we've got a 1 here, we've got a 2 here, we've got a 3 here, but I also have these delineations as well. And so this is a 2.5, and this right here is a 2.6. And so I can be more precise in my measurement. And so what is the length of the wasp right now? Well, it's 2.55 centimeters. And so this right here is a more precise measurement because I have a more precise measuring device or a more precise ruler. These numbers, 1, 2, 3, are called significant digits or significant figures. And so this measurement would have 3 and this measurement would only have 2. So let's play around with some of these things. What kind of digits are significant? And there's 4 types of digits that are going to be significant. And so if you're working through a problem and you see a non-zero number, so let's say you see 32.6, how many significant digits are there in that number? Well, the 3 is, the 2 is, the 6 is, and so there'd be 3 significant digits. Or let's say we had this measurement, 12.48. That would have 4 significant digits because there's no zeros in it. So that's pretty easy. Let's go to the next one. Final zeros after the decimal place are always going to be significant as well. So what does that mean? Let's say we've got 2.0. How many significant digits are there? Well, this 2 is, and this 0 is also significant because it's a final 0, in other words at the end, and it's also after the decimal place. And so this would have 2. Or if we did something like this, 28.40, well, 1, 2, 3, and now this one, according to that second rule, is also going to be significant. So we'd have 4 significant digits right there. Okay, what else is significant? I like to refer to these next ones as sandwiched zeros. And so let's say we have 209. Well, this is significant, that is significant because they're not zeros, but this one is sandwiched between the 2, and so it's also significant. And so you could have, for example, 12.090. Let's apply all our rules. How many do we have now? Well, these guys are all significant. This 0 is sandwiched between the 2 and the 9, so it's significant. And this one is a final 0 after the decimal place. And so this right here would have 5 significant digits. So it seems like everything is significant. Let's go to the next one. All numbers in scientific notation are significant as well. What does that mean? Let's say I have a number like this, 380000. In science, we use what's called scientific notation to write this out. And so if the decimal place is here, remember I can count back 1, 2, 3, 4, 5, 6. And so we would write this as 3.8 times 10 to the 6th. That's significant, and so this would have 2 significant digits. All right, so then let's go to the next page. What actually is not significant? So what numbers aren't going to be significant? Well, there's only one group of numbers that aren't, and those are placeholding zeros. And so an example of that, let's say you had 230. Well, this is significant, so is this, but this 0 right here is just spacing the numbers 2 and 3 from the decimal place, so it's a placeholder. And so we would now say that's not significant, the only thing has 2. Or if we take a number like this, 0.00069, how many significant digits are there? Well, all of these zeros are simply placeholders, so they're not significant, and so we'd only have 2 significant digits there. Okay, so what do we do? Well, in calculations, you have to make sure that your answer is no more precise than the measurements that you actually make. And so we're going to try some calculations, or we're going to try some practice. And if this doesn't make sense, slow it down, go back again, and take a look. So let's start with the law of multiplication and division. Law of multiplication and division says that the number of significant digits in the answer should equal the least number of significant digits in any of the numbers being multiplied or divided. What does that mean? Let's try one. So for example, let's say we take, I have one down here, 26.4, and we multiply that times 120. Okay, if we multiply those numbers in a calculator, we get a really large number. It is 216. 8.000. So it keeps going like that. So what do we get for an answer? Well, this has 1, 2, 3 significant digits. This one has 1, 2. That's not significant because it's just a placeholder, so that has 2 significant digits. And so since this one has 3 and this one has 2, my answer can only have 2 significant digits. So what does that mean? I'm going to have to round. And so there's 1 significant digit. The next one, the 1, is the second significant digit. And since this number right to the right of it is larger than 5, or equal to 5, I'm going to round this up. And so what is the right answer? The right answer is 3200. How many significant digits does this have? Well, these 2 zeros here are just placeholders, and so this is going to have 2 significant digits, which is equal to the least number in my 2 calculations. And why do we do that? Well, we want to make sure that the measurements we make are no more precise than the answer that we get at the end, or the answer we get is no more precise than those measurements. Let's try another one of those. So let's say we're doing division for a second. We'll make an easier one. Let's say we take the number 19 and we divide that by the number 3. What do we get for an answer? Well, in our calculator, we get 6.3333. It just keeps repeating like that. But you would never turn in an answer like this in science class or in math class because it's way more precise than the measurements we actually made. And so let's go through and use our rules. How many significant digits does this have? 2. How many significant digits does this measurement have? 1. And so how many significant digits can my answer have? Well, it can only have 1 significant digit. And so what is my answer? Well, this is a 6, this is a 0.3, and so my answer would be 6. In other words, I'm going to use this number to round so I can get to 1 significant digit. And so the answer wouldn't be 6.33333. The answer would simply be 6. And so significant digits actually make your job a little bit easier. Now, addition and subtraction is a little bit different. In addition and subtraction, it's the number of decimal places in the answer that should be equal to the least number of decimal points or decimal places in any of the numbers being added or subtracted. What does that mean? Let's say we have a measurement like this. 13 plus 1.6 equals blank. Okay, now in this one, we have to look at the number of decimal places. In other words, this one is measured to the ones place, and this one is measured to the tenth places. And so even though the answer, if we add these up, you can see is going to be 14.6, my answer can't go and give me another decimal place right here. And so the right answer would be 15. In other words, I have to round that 4 up to a 5 because I can't get an answer that has more decimal places than my least decimal placed answer to the right. And so addition and subtraction work that way. Sometimes when I'm solving these ones, what I'll do is I'll line them up so all the decimal places are on top of each other, and then I can see which one has the least number of decimal places. Okay, so if we go to the end, I said, after you watch this, you should be able to answer a question like this. So let's take a stab at it. So this is 10.6 meters. How many significant digits would that have? It's going to have 3. Now we've got 13.960. How many significant digits does that have? 5. And so my answer can only have 3 significant digits. So even though my calculator might say the answer is 0.75931 2321, I don't want to turn this answer in. I want to get an answer that has 3 significant digits. And so the right answer would be 0.759. That's it. Because this is 3, I'm not going to round this 9. And so the right answer would be 0.759. So that's how you do significant digits. Best way to get better at doing significant digit problems is to just practice them until you eventually get it right. And so I hope that's helpful. And always come ask for help if you get lost.